Hello everyone, in this video I'll be explaining the problem Stone Game 3. So I would highly recommend to watch my previous videos. I'll tell you which videos. First, if you see this question, it is hard, but if you watch my previous videos, I've made a video on predict the winner, which is kind of the same problem, and then you watch my Stone Game problem. So once you watch these two solutions, so definitely you will easily understand the Stone Game 3. So if you directly come over here, you may feel it's very hard, but if you follow those two videos, it will be good to start with the solution of this video. So okay, let's read out the problem. Alice and Bob continues their game with piles of stones. There are several stones arranged in a row, and each stone has an associated value, which is an integer given in the array stone value. So Alice and Bob take turns, with Alice starting first. On each player's turn, the that player can take one, two, or three stones from the first remaining stone in the row. Okay. So the score of each player is the sum of the value of the stones taken. The score of each player is 0 initially. The objective of the game is to end with the highest score, and the winner is the player with the highest score, and there could be a tie as well. So the game continues until all the stones have been taken. Assume Alice and Bob play optimally. Return Alice if Alice will win, Bob if Bob will win, or tie if they will end up end the game with the same score. So yeah, let's go to iPad and try to understand. So if you watch this predict the winner, so I have explained how this works. It's a DP problem only. So then you can watch my Stone Game video. Okay, once you've understood these things, then we'll come to Stone Game 3. So we have Stone Game 3. So in the problem statement, what they've then given is they'll give an array. Okay, let us call array as A, but there they have set stone value. Let's call this array A, and its length is n. And there are two players, Alice and Bob. Alice will start the game. Basically, she will play first. Okay, which means she plays first. Then Bob's turn will continue. So it's like first Alice will start, then Bob will play, then Alice, then Bob, this way. So in the question, what they've said is initially Alice score is 0, as well as Bob's score is also 0. And we have a pile of stone in the array. If you consider array as a1, a2 up to so on, an minus 1, an, there are n elements in the array. Let me take a3 as well. So since Bob is gonna start the Alice is gonna start the game, so Alice may choose three elements. Okay, at max three elements she may choose from the starting of the array. If you consider starting of the array is a1, a2, a3, and up to so on an minus 1, and then an. So Alice, if she chooses just one element, so her score, Alice score is gonna be a1, and the remaining element, uh, remaining array is gonna be a2 to an minus 1, an. Okay, this is the case one. What if she wants to choose two elements? If she wants to choose two elements, Alice score is gonna be a1 plus a2, and the remaining array will look like something this way, right? And the third case is she may choose all the three elements from the starting of the array. So her score is gonna be, and the remaining array will look like something this way, a4, and then we have an minus 1 and an. And Bob, once we pass, let's say Alice has just chosen one element, so she'll pass this array, and Bob will have this similar option. He may choose first element, just one element, or two element, or three elements. Okay. Similarly, in this case, when Alice has chosen two elements, so she have should have passed this array from A3 to N. So now Bob may choose one element, or two elements, or three elements. Similarly, goes for three elements as well. Okay, Bob may choose one element, or two element, or three element. So I think you have understood now. It's kind of choice. We'll choose the elements of the array, either one element of the array from the starting, or two elements, or three elements. So whichever gives me maximum value. Once I choose let's say just one element, and Bob is again gonna play optimally. Bob tries to win the game. So Bob will also choose in an optimal way. So after choosing the element, whatever values we are getting from the recursive function will add to our scores. So in this case, when Bob achieves just one value, let's say our score is S1. Okay, S1 we have some score. Similarly, in second case, we'll have S2 some score. Similarly, S3 some score. Now, depending on these three, whichever has maximum, whichever has maximum score, so that score is gonna choose by Alice. Similarly, Bob will do the same thing. So at the end, uh, when we come out of when we have done all the computations, we'll have the score. And I think in the previous videos we were taking pair of int comma int as the return value of the helper function. Okay, so first value always contain Alice ka score, and second value will contain Bob's score. So we will compare if whatever the score written by helper function, if both the scores are equal, then we have to return tie as the string. If Alice score is greater than Bob's score, we have to return Alice has won the match. The other way around, if Alice score is less than Bob's score, then we have to return Bob as the answer. It means Bob has won the game. So I think this is pretty much about the problem statement. So now if we try to build the helper function, before that let's take the base case. What would be the base case? Since our array is from A1, A2, A3, A4 up to so on, AN minus 1, AN. So we are starting from the zeroth element of the array, or you can say based on one indexing, we can say first element of the array. So our pointer is moving from left to right, right? So when this pointer is crossed at the end, which means when it points to I greater than equals to n is basically size of the array. So in that case, since there are no stones, we have to return 0 comma 0. Why 0 comma 0? Because we'll be returning pair of values. The first value will make sure it is Alice score, and the second value will make sure it's a Bob's score. Okay, so since we don't have any element to choose, so their both scores will be 0 at the end. This is the base case, right? Now if we go to helper function, there we'll be passing one variable which is I, and we'll say Alice turn as the boolean variable which has value either true or it has false, right? So if Alice turn is true, which means it's Alice turn. If Alice turn is false, which means it's a Bob's turn. Then we will pass this array A, or it's a stone value vector, we can say. So we'll check the base case as described above. We'll check base case. So once we have checked the base case, what we are going to do is we are going to check If it's Alice's turn, so Alice is gonna play, else Bob is gonna play. So I'll be writing just the helper function for Alice. Similarly holds true for Bob. So initially we'll take one score. P of I is basically pair of integer and integer. We'll take one variable score, and at the end of the helper function we are going to return the score. Okay, I think if you watch the video, you will understand like what I'm trying to say here. But yeah, still I'll try to make sure this video is good enough to understand. So as I said, like there'll be three choices, right? We have three choices. So in the first choice, what is going to happen is, um, let's call, we can say score one. In score one, which means Alice has chosen just one element. Okay, so if it has chosen one element, so your I pointer will be pointing to the next element now. So in the array, A1, A2, A3, A4 up to so on A1 we had. So I was pointing here. Now Alice has chosen just one element. So Bob now can choose from I plus one element. So that's the reason I'll be passing I plus one, and I'll be flipping this Alice turn variable, which means it is going to pass as false, which means in the next turn Bob is gonna play, and I'll pass this array. So whatever value we are getting in score one, it will be a two values. Okay, the first value will be a score of Alice, the second value will be a score of Bob. So since we have chosen the first element, so in this score of one dot first, we'll be adding the element A of I, or basically A is array, you can say A of I. Okay, so it's like we have chosen the first element, and whatever score we have initialized, this is the score that will be returning. So we will make sure the score is right now score one only. This is my optimal solution, I'll say, for time being. Next, I'll try to choose to score, and I'll call a helper function, and it's like I've chosen these two elements. Okay, and my I was here, so I've chosen I and I plus one. So next, Alice is gonna choose from I plus two element. Okay, so I'll be passing here I plus two, and I'll flip this Alice turn, and then I'll pass this array. Okay, so I've got a score 2 as well, which will again have two values. First value will be Alice score, and second value will be Bob score. Now, what we can do is we can check. Now we need to check if this score, whatever we got, okay, if it is greater than the initial score what we've got. So we need to check if the score dot first. Since we have initialized score 1 with the score, so it's like the first element we have chosen, so its score is in score. So if it is lesser than the score 2 dot first, which means after choosing two elements, okay, after choosing two elements, our score was more. So if that is the case, then our score will be definitely score underscore 2. So this will be taking. Okay, and two scores we have chosen. Now the third one will be uh, okay, one second. So helper is here now. Okay, so since two scores we have chosen, now we have to add the two values, like we have added here a of 1, right, in case of 1. So similarly we need to add two values. So when you'll be adding two values, you will have to compare if I plus 1 is less than n, which means we have capability of choosing two elements. Then in this score of 2 dot first is plus equals to array of I plus array of I plus 1. I think now you have understood why it is I plus 1 less than n. So we are adding two score values, and then we'll be comparing this score of first dot less than score underscore 2 dot first. Similar thing will go with the third case. Okay, now the third case, he'll be choosing, sorry, Alice will be choosing, she'll be choosing three values. So score underscore 3, we can say it is gonna be helper of, since we are choosing three elements like I plus 1, I plus 2, then from the fourth element Bob is gonna choose. So we'll be passing I plus 3. I plus 1 is here, I plus 2 is here, I plus, sorry, I plus 1, I plus 1, I plus 2 will be chosen by Alice. Now Bob will choose from I plus 3, and we'll flip this Alice turn and we'll pass this array A. Now similar thing we'll check if I plus 2 is lesser than n, then in the score 2 dot first we are going to add array of I first element, second element plus third element, right? I think we're understanding. So once we have this, now we'll definitely check if score dot first is lesser than score 3 dot first, then our score will lean towards score 3, because after choosing three elements I've got a maximum value, right? So else case will be a Bob's case. We can say Bob's case, it will be same thing, just whatever, whenever we have first, we'll be you'll be putting there as second. By second means it's a Bob score, okay, and at the end you're going to return the score. This is a helper function, and yeah, this is going to pass the basic test cases, but it will not pass all the test cases because the length of the array is 5 into 10 power 4, so it is not going to pass. Now we'll be solving it DP way, but yeah, first let's try to write the recursive function, then we'll focus on DP. I think the recursive steps you guys have understood. It's very easy. So this will be our final stones. We can call stones not scores, because stones at the end we're correcting. Stones is gonna be helper function we'll call, and we'll start from 0, and initially it will be Alice turn, and we'll pass this stone value. Okay, now we'll define pair of int comma as PII. The helper function return type is pair of int comma int. We have I and we have Alice turn. Then we'll have this vector. Okay, and vector is stone value. As I said, base condition is going to be if I is greater than equals to n. What is n? And let's define n will be stone value dot size. If it is greater than equals to n, which means we don't have any element to choose, both Alice and Bob score is going to be 0 in this case. Now we'll have one variable scores. We'll check if it is Alice turn, which means it's Alice turn, else it's a Bob's turn. If it is Alice turn, now what we need to do, we have to check. We can call stones not score. Okay, stones 1, you will take a variable and we'll call a helper function. And since one stone has been chosen, so from next stone, it's a Bob's turn to choose. And we'll flip this list turn value so that in the next turn, Bob is gonna choose, right? So once we have the value of, both Bob and Alice after calling the recursive function, so we need to add the current number of stones. So since we have chosen just one stone, so it's gonna be just this thing, right? In the Alice score we are adding. So similarly, when we are adding for Bob, it will be second because a pair of increment, whatever we have, first value is Alice score, Alice number of stones, and second value is Bob's number of stones. Okay, once we have this, now our stones will be initially this stones of 1. We'll say this is my optimal solution for now. Now we'll be checking, we'll be considering 2 stones. So when you're considering 2 stones, so you'll be, Alice will be choosing ith stone and I plus 1. So the next, the Bob is gonna choose is from I plus 2. And we have stones of value, right? Now we need to check if I plus 1 is lesser than n, then only we are, defining basically 2 stones will be considering. If there are just one element, so you'll be choosing just at the end, if you have just one element, so you'll be choosing just one stone. If you have 2 stones, you have the possibility of choosing 2 stones. So for that reason, I'll be checking this if I plus 1. Okay, so in my stones of 2 in Alice score, we are going to add I and I plus 1. So basically we are choosing 2 stones. Now we need to check if the stones dot first, since we have chosen, this is my current maximum answer. So we are choosing the current maximum answer of Alice with the second option. When we are choosing with the 2 elements. If Alice score is greater here, so our score, number of stones will lean towards stones of 2. Understood, right? Now similarly, it will be a third case where we will choose 3 stones. So when you're choosing I plus 1, I plus 2, the next stone will be I plus 3, which will be chosen by Bob. So again, we'll have to check, do we have those many stones? I plus 1, I plus 2. If we have, then only we need to make sure we are adding it to 3 stones. Alice score, right? So once we have these stone values, so you'll be checking from these 2 stones will have definitely the current maximum in the stone variable. Okay, so we'll be checking what is our current maximum number of stones chosen. If that is lesser than the stones of the stones, if you're choosing 3 stones first, okay, then definitely our number of stones will lean towards this thing. Okay, so we have this. Now similar thing will go to the Bob's computation. So in case of Bob computation also it is going to be the same thing. Just whatever we have here first variable, it is going towards the second because Bob's score is put in the second variable in the helper function. Okay, so we have these things, and at the end don't forget to return the stones. Let's try to run it. Stones value. Okay, somewhere we have missed. It's a stone value, not stones. Let's try to run it now. Okay, once we have calculated the stones, now definitely we have to complete this function. So we have, Alice stones in this stones dot first variable. Similarly, we have Bob stones in this stones dot second variable. We have to check if Alice stones equals to Bob stones, then in that case we need to return tie. Else we have to check if Alice stones greater than Bob stones, which means Alice has won. Now we have to return Alice. Else definitely we have to return Bob. Let's try to run it. So it is getting passed, but if we run this solution now, it is going to give us time complexity. The reason being is, I'll tell you. Let's go to iPad. So whatever array we have, right? We have elements A1, A2, A3, A4 up to so on till AN. So this stone will either be chosen by, Alice, or it will be chosen by Bob. So we have two options here. So these stones can be chosen in two ways. These stones can be chosen in two ways. This stone can be chosen in two ways. Similarly, I mean, in total, how many elements are there? It is 5 into 10 power 4. So it is going to be 5, even if you do, it will going to be 10 power 4. Okay. So it's an exponential solution. We can say 2 to the power n, exponential. And definitely it is going to give us TLE. Now let's move towards DP, because here we have a repeated state. Definitely. So when there is a repetitive steps, I mean, we have to maintain the states. Since we have calculated for particular I and the Alice turns value, so we have to maintain those states. So as you can see in the program, the changing variables are just I and Alice turn. These two are changing, so we have to maintain a DP of two states, I and turn. So yeah, let's go to saving the state and then passing DP. So once we have already calculated those state value, so we don't need to again calculate it. Recursion does calculate those things one more time, but since we have already calculated, we have to show those values, and we have to pass it back without calculation from the DP state. So I can move from 0 to n minus 1. So I've taken n states, and the reason why I'm taking vector of pair int comma int is that in DP states will be storing two values, Alice score and Bob score. So this turn, whatever we have, right, it is either true or false. So true means it is 1, 0, false means it is 0. So in two states we can maintain, and I'll be initializing all the states with pair of minus 1 comma 1, minus 1 comma minus 1, which means initially all Bob and Alice scores are minus 1. Now let's pass this TP state, right? In all the helper functions, we're going to add DP. And before returning this particular score, I mean stones, we'll have to maintain this state. And before computation, we'll have to check if the Alice score is not equals to -1, which means already visited, and Bob's score is also not -1, which means it is already visited, then we need to return simply their value. Let's try to run it now. It is getting passed. Let's try to submit it. So it got accepted. So here the time complexity of this solution is you know uh, quadratic, which is n square, and space complexity is also n square. I mean, it is not n square, we can say 2 into n. The space complexity is just 2 into n, and the time complexity is also 2 into n. So yeah, thank you guys for watching the video.